I don't think that would actually slow us down very much. Everyone who's analyzing those.
And I think because of the idea that we get issues are so much divergent already from the process.
Yep. Show them then.
Okay, folks, I think it's time to take our seats and get cranking for our second session of the MLS at IETF 104. Well, welcome again. The blue sheets are going around. As I said earlier, this is the MLS session at IETF 104. If you're in the wrong place, you can either stay and learn a little bit or take off, your call. The chairs are Nick and myself, and the secretary is Cottrell. I guess he had to take off to go back home, but he'll be watching, I'm sure, or listening. Here's the note. Well, it's Thursday. Hopefully you've seen it by now. Basically, anything you say and do will be used against you. You're going to be recorded. You get to the microphone to talk. If you know about IPR, you're supposed to disclose it. If there's any kind of problems, you can talk to the ABUDS team. And there's a bunch of BCPs to tell you about how the internet standards process works, codes of conduct, and all kinds of other things. If you have any questions, you can ask us or follow the links that are in the note well. Requests. We need a minute taker and a Jabber scribe before we can proceed. What's nice about being around here for a long time is you know a lot of people's faces. And so you can basically wait for a couple minutes and then you just pick someone. So again, minute taker. All we need to know is decisions. We don't need minute by minute, blow by blow. All right, Chris, you're the man. And a JabberScribe, please. All right, cool. Now, since we actually do use Wire, I don't know, is anybody in Wire? All right, well, it's not really required. Sean, the blue sheets as they're coming around. Obviously, when you get to the microphone, please state your name at the mic. Depending upon the mic, you may have to eat the mic, so don't be offended if somebody says eat the mic. That just means get closer. Let's keep it professional at the mic. So our agenda, excuse me, for today, it's on the right. So the protocol, we're going to start off with the issues in the protocol draft. We actually discussed the simplified key schedule, and I don't know if you think we need to redo it today because Ahmad's here, Richard, or what, but we can. The other issues that we're going to talk about are common framing and lazy updates, and then Ahmad and Raphael have some stuff on federation, which we talked about at the interim. And then Sophia is going to talk about some deniability things that we can do. Kartha is going to give us a formal security analysis update, and then we're going to try to do some next interim planning. Richard?
Yeah, I don't think we need to go back to issue 90. I'll talk to Ahmad one-on-one.
Okay, great. I love it. All right, so that just means that Raphael is up. Hey, Raphael, here's the clicker thingy.
Yeah.
Then you're in charge. Cool.
Good morning. All right, so we're going to start with common framing, which is something that we've been discussing for a while, and now there is at least one concrete proposal. So to give a bit of context, and also to state clearly what problem we're trying to solve on the security and privacy level. The idea is to find a common format to encrypt handshake and application messages. The reason behind that is that, for example, add messages and remove messages can leak information about who has been added to the group and who has been removed. In particular, add messages have the identity, the credentials of the members. And so if handshake messages are not encrypted, that information lives in these messages in clear text. And since handshake messages have a certain lifetime, you expect them to be stored on a server for a certain time until they're finally being delivered to the client. This is information that is stored on disk in the cloud somewhere. And so if you look at all the add and remove messages, you can infer who is actually in the group. So this is the problem we're trying to address here mostly, is to protect the identity of members. There are some conflicts when you start encrypting handshake messages. One of them is that in the past we've been discussing the concept of server assist, where the server could provision new clients with public keys in a tree. So the server would basically maintain a view of the public keys of the ratcheting tree, so that new clients wouldn't have to get that information from existing clients. And it would simply be more efficient if that could be retrieved from the server. So this becomes impossible, of course, if you completely encrypt handshake messages. At IETF 103, I think Ecker made the point that the best strategy would be to first encrypt handshake messages and then later think of what needs to be leaked to the server in order to build the trees of public keys. So this is essentially what's happening now. We are encrypting first, and then we can selectively, additionally leak some information to the server. The other thing is that encrypting handshake messages mostly only makes sense in a scenario where the server shouldn't know what the roster is. So just as a reminder, the roster is the list of members in a group. If it's the requirement that the server should know what the roster is, then there probably needs to be some mechanism how the server gets updated on that as well. And then encrypting handshake messages might not be necessary or even be counterproductive. So we're looking for a common framing for both handshake and application messages. So the struct on the left here has a header with some metadata, the group ID. So every message, be it handshake or application, pertains to a certain group, a certain epoch of that group, and comes from a sender, which is a member of that group. In addition to that, we distinguish between different content types, which at this point in time is only handshake and application. Could be more in the future. And then finally, we have the payload of the message, depending on whether it's a handshake or application message, and the whole thing is signed in the end. So this is a plain text MLS message. So we have two proposals currently. One is a proposal where we encrypt all the things we just saw on the previous slide, but we keep certain data in the clear. So the left struct here, the MLS inner plaintext, basically it's just an instruction on how to serialize the plaintext message we saw earlier, how to append the signature, how to get padding for free. And on the right, that is now the encrypted message, but you will notice that the group ID, the epoch, the sender, and the generation are still in the clear in the header of that ciphertext. So the ciphertext is is the MLS inner plaintext from the left. And just as a reminder, so the generation is for a given sender in the application key schedule. We have forward secrecy and we hash ratchet forward, and the generation then basically indicates where we are in that chain. So this is the one proposal. The other one is slightly more involved. And the idea here is that the data we saw previously in the header, meaning the sender and the generation, are additionally also encrypted. But they have to be encrypted under a different key. We'll get to the encryption keys in a bit. So what we do here is on the lower left side, we see the alternative 2 for the MLS ciphertext struct. So what we still have in the clear is the group ID and the epoch, and there is no way to properly obfuscate that at this point. We also have the content type in the clear so that we can distinguish between handshake and application messages. And this is important because for now, we assume that with TreeCam, we need strong ordering for handshake messages. Maybe not update messages, but add and remove messages. For now, they require strong ordering. Whereas application messages do not have that requirement. So if we conflate the two in a common struct, it shouldn't be a requirement that application messages now also inherit this property of being strongly ordered on the server side, because that could be problematic since we expect there to be many more application messages than handshake messages. And that could lead to problems like starvation if the server needs to tell clients that they have to re-encrypt because the epoch has changed there. So we expose this in the clear. And then the sender data, which we see on the upper right, the sender and the sender generation, that will then be encrypted under a group key. It cannot be a sender specific key because we don't know who the sender is at that point. We just reveal that inside. And then there is some additional indication how the data should be authenticated in the AED scheme. So in particular, the sender data and the fields for the ciphertext. So regarding the keys, application messages as such are unchanged. They are being encrypted with a per sender key that comes out of the application key schedule. For the handshake messages, the idea is to derive a new key from the key schedule. And in terms of authentication, so we have the AID authentication that ascertains that a certain sender is part of the group. Then the whole message is signed as such. So once we know who the sender is, we can also verify that signature. And then with the confirmation key that comes out of the group key schedule. So in this scheme, we have signature that covers the MAC instead of MAC covers signature, as it's the case in TLS. And it remains to be seen if that is actually a good thing to do from a security perspective. And yeah, as a note, Sigma is agnostic of that because neither covers the other. Yeah, that concludes that. In the end, we have some open questions. So one of the questions is it fine to reveal the content type? So just as a reminder, that is what is in the clear now so that we can distinguish between application and handshake messages. Do we leak some information that we shouldn't leak by revealing that? The other option is, the other question is it worth encrypting the sender and the generation? I mean, there is no cryptographic identity in the sender. It's really just an index. So if you don't have the roster, you cannot clearly say who the sender is by just looking at one handshake message, but you could still aggregate that data and get a better view on what's happening in the group. And then for academia, the question is whether we're fine with switching the order of signature in MAC as opposed to TLS.
So I don't have an opinion with the last point. My understanding from reading Sigma is that's technically okay, but like whether it's a good idea, like I leave to people who know these protocols better. I mean, I generally aim towards encrypting as much as I can, unless I have to, as I think apparently I said last time, though I don't recall. With a content type, it seems to me that with the content type, we have a somewhat difficult problem, which is that we're trading off two values. One is key separation between the handshake and the content data, which otherwise it was otherwise nice to have for analysis reasons. And the second is revealing the content type. Now is leaking that information. Now there's sort of like an abstract reason not to like that because just generally leaking information you want to have is not good. But there's actually not like fantastic, but like sort of concrete attack that is allowed by revealing the content type, and it's this: if the if you don't force sequencing, it is basically that it allows the attacker, the message delivery service, maliciously to basically gag updates from a given client by basically just not sending them, by just removing them from the message stream. Unless you have forced sequencing between them, then you have a problem. Now, maybe you could have forced sequencing and that'd be fine. But I think Richard was telling me you didn't need forced sequencing. The idea is like that I shouldn't be like, obviously you can just take me out of the group by not letting me send messages, right? But what you shouldn't be able to do is allow my messages to get through, but not let me rekey. And so, if I think when I talked to you earlier, you said that it wasn't important to have those sequenced, but it potentially is, because otherwise what will potentially happens is the attacker says, well, it's fine if like Ben talks to the group, but I don't want to let him rekey. So every time I see a handshake message come up, I just drop it on the floor. So obviously having the content type revealed makes that easier. Though potentially you can still have sequence numbers and it'll be fine. It's also the case, obviously, that you learn more about the group structure. If you're an observer by the content types are leaked.
Right. Yeah, I mean, just to be clear, so for now, the assumption is that handshake messages need to be ordered, and application messages don't. I mean, that might be wrong, but that's the status quo right now. To the point that the content type might reveal some information there, the point has been made that this could also be revealed by just looking at traffic patterns, because handshake messages have a certain size and they're not necessarily indistinguishable on the network from application messages. That's a point I forgot earlier.
Yeah, I mean, that's certainly true. I think obviously one could go to some effort to make that not the case, that we have padding and those kinds of things. I think, I don't feel like, as a matter of principle, I guess I'd prefer not to have it this way, but like maybe it's the case we just have to. I guess there is one by the, when we looked at this in TLS, there is like one way to get away without having to have the content in the clear, but it's called key separation, which is do trial decryption. So that is like not awesome, but like, if handshake messages are very rare, then you just do application trial decryption, and then you use the handshake key if it fails. Like, again, I don't know, this is like kind of a little abstract. And before I like signed on for trial decryption, I want to hear the cryptographer say it was okay.
Yeah, that's clearly the consequence. So if you drop the yellow content type field here, you would have to try a number of keys basically to then see who the sender is.
This is Inokan Gilmore. So when you say a number of keys, I believe it's the 2, right? Yeah, 1 is also a number, Ecker points out. So I want to echo what Eric just said, which is that and point out that these choices that are proposed here in these slides are pushing us in the direction of turning over significantly more information about group structure and group and traffic analysis to the delivery server. And those are significant architectural changes that grant the delivery agent significantly more power in this context. And if that's what we would decide we want to do, then we need to make that pretty clear, I think, in the architecture document, because I'm not sure that the architecture document currently acknowledges how much power the delivery server has. I believe this is a significant increase in the power of the delivery server. I'm not happy about that. I would like this scheme to put less power in the hands of whatever centralized agents we actually have to put up with.
Which information are we talking about exactly, apart from the content type?
Specify. So you had two main questions about. Sorry, you had two main questions. One is about the content type, and one is about whether the sender and generation need to be encrypted. And right. the more that we expose in both of those, the more power the centralized agents have.
Right. I mean, for the content type, this is what is being exposed, I think, in both proposals, whereas the sender and generation, this is obfuscated in the proposal number 2 here. Yeah. Just to be clear about that.
What's in the proposal, in the PR we have up right now, exposes all of this. And so the additional proposal today is to protect the generation and sender. That's why we were reacting kind of puzzled by your comment, because we're increasing relative to what's in the PR right now. The only thing is that we're still revealing the content type. So I think we're aligned on protecting the sender and generation, those aspects. It's just the question of whether these questions about ordering are sufficient to justify exposing the content type.
Okay. So, sorry, I'm responding to the question that if you can move the slide to the slide that has the questions that basically says, is it worth it to protect the sender and generation? And I'm saying yes.
Good.
I'm not okay with revealing the content.
Ben Kaduk. So I'll note that in our charter, we are not explicitly chartered to encrypt as much as possible in the way that TLS was. TLS is explicitly chartered to encrypt as much as possible in handshake. But we are chartered to learn from the lessons in other protocols like OTR and double ratchet and whatnot. And that would sort of lend to support in general the idea of encrypt as much as we can, which I think has been mentioned a couple times already.
Maybe we can change the wording there, Benjamin. I think for now we say that we try and obfuscate as much as possible data that is personally identifiable data. But encrypting as much as possible is probably a much stronger wording.
Hi, Karthik Bhargavan, Indria. So relative to the question asked there, switching the order of signature in Mac, usually not a problem. In fact, at some point I suggested in TLS 1.3 that we should switch the order. Unfortunately, the Mac is called the finished message, so it would have been weird for it not to be the last message, and so we didn't do that, or I didn't propose that. But it would actually, in some cases, it helps. So we can look at it, but I think it'll be okay. Second thing is that we really do want the keys used for handshake to be different from the keys used for the application data. Also because for compositionality in proofs, it's critical. But more practically, you want to think about it as, suppose when decrypting the handshake message, you then look at the format and you leak something somehow. Okay, so the decryption of the handshake message leaks something. We do not want that to affect the leakage of application data, because an attacker will take an encrypted application data, send it as a handshake data, see if you manage to decrypt it, and then see what comes out of it. And if it comes out and says, oh, this is not a valid handshake message, it's revealing something about the application data message I sent to you. So you have to be careful about this. That's why we really love key separation and really highly support that. Also, yes, we should try to encrypt sender and generation. For the content type, the only point I would say is I don't see a very strong reason for hiding it, but the motivation you came up with was that the handshake messages are ordered, but the data messages are not. But the ordering there is not, I think, it's not sufficient motivation in some sense, because even the data messages have a causal ordering. So you can think that suppose every message, instead of saying I am message number I, were to instead say I am causally coming after message number J, then the same property would hold for both the data and the handshake. In the handshake, we know that there's only one message after J, which is J plus 1. In the data, there could be many messages which are causally related to J. What?
They have to address each other. The handshake has to refer to data messages.
It just has to say what is the previous message indeed that I'm causally related to. Yeah, I'm not suggesting that that's a reason. I'm just saying that we could weaken the ordering constraint in both, and it would be sufficient for a lot of use cases.
Okay. Thanks.
Oh, you were staying right there. I didn't think you were lying.
Benjamin Barduche. Yeah. DKG just pointed that actually we could do trial decryption and hide both. But it's, trial decryption. I mean, we could definitely encrypt the content type as well under a secret that's known only by the group. And that would be a solution that we would have to trial decrypt.
Yeah, but clearly the consequence is the server enforces strong ordering on application messages.
That's true as well, yeah.
So this is DKG, and sorry, you said a phrase that's kind of, I don't know if I could call it a pet peeve of mine or whatever, but you said personally identifiable information, we want to hide it. I don't know whether that's actually in the charter. If it is, I missed it.
I think it's in the architecture doc, but I might have
okay, so let me just say, personally identifiable information is a legal fiction, and it is far more fiction than anything else. The history of re-identification and de-anonymization and all the other kinds of research that have gone on make it quite clear that personally identifiable information is not a coherent category. And there's much more important things beyond personally identifiable information that can have concrete harms when we expose them. So I want to make sure that as a group, we aren't just thinking that what we need to protect is personally identifiable information, because that particular term is something that lets people sort of miss the forest for the trees, right? It's very easy to say, oh, well, that's a social security number, or that's a bank account. Let's ignore it. Let's protect that, but the rest of the stuff isn't that important. This is messaging. The content of my message is not PII, but we're trying to protect it too. So I just wanted to call that out. If you find yourself thinking, oh, well, is it PII? That's I think that's a dangerous way to think when we're trying to design strong security protocols.
We could certainly make some changes in the architecture doc in that respect.
Yeah, I think, I mean, I basically agree with DKG that, regardless of what stuff, we put in our charter, I think we should be trying to encrypt as much as is feasible. Now, the question of this is feasible is an interesting question, but unless there's a concrete reason for, if we have to, all other things being equal, unless there's a concrete reason for this data to be revealed, it should not be revealed. to the point Karthik was making, what I want to sharpen here is what's important is not just the ordering of handshake messages, but the ordering of handshake messages with respect to the data messages. Because as I say, the attack I'm trying to prevent is one where I'm apparently a member of the group, but I'm just never allowed to update my key material. So it's fine to have like some sort of partial ordering of messages, but it's got to be the case that basically that the receiver can see that there's like a missing message out of my flow that was like a handshake message that is no longer there. Now you can get that by just having one set of sequence numbers effectively that span both keys. I have no idea like what that does in any kind of key separation guarantees. It's probably fine, but like you can certainly get that. So I certainly am not trying to say you have to exclude the content type in order to get this behavior, or have to encrypt the content type in order to get this behavior. But I'm just saying like that's the property you need if you're at this attack. And you could also just say like this is a dumb attack, and like I don't care about it. I don't think that's true, but one can say that.
So just in the interest of making progress, I might make a suggestion for how to move forward here. It seems like there's pretty good consensus that we should be protecting the sender and generation. We should do that bit of things, but less certainty around this content type thing. Like there may be some attacks here. There may be some engineering constraints that make ordering hard. So I'm kind of, I think what I might propose is like, let's go ahead and do basically what we've done on the slide here, expose the content type for now, but kind of file a new issue, continue to think about this ordering question, think about whether we can also hide this content type in a future version. Does that seem like a plausible, just like incremental work strategy here?
Well, I guess we're not quite at the quick stage where we're like, having to, have like an act of Congress in order to file a new issue. So I think I'd certainly like to keep the question of whether we can encrypt the content type open. And I think the question of whether or not we're trying to prevent so key update suppression, you actually have to grapple with. So I think, that I don't think you can punt. I'm happy to sort of like, in making progress, take this PR and then like have an issue for the content type that we can deal with later as, maybe DKG and I and others who care about this can sit down and try to like reason about a better way to do it than like the kind of clumsy ways we've come up with so far. But I think we have to address the ordering question at some point, though I'm happy to not do it right now.
Yeah, I think the subtext of that proposal is that I think we're trying to get in the next few weeks to a version where we can start have a bit of stability and a bit of interop and a bit of analysis. And so like if we could go ahead and address the sender and generation privacy in that version, and then like in the next version. Yeah, okay.
Academic hat on. I think this looks pretty good, but we have to do some analysis. In my analysis slides, I will say, and I want to say this for this one as well, this is a new feature that has a specific goal with respect to privacy. I would prefer any such new feature to also come with a as crisp as possible, even if informal, definition of what the privacy or security goal is trying to address is, why the previous design does not address it, and why we think this addresses it. Will give us a clear target for analysis.
Good point.
So I can sort of answer that question. I think the original thing of the common framing is not to encrypt the message. It's just like to keep everything under the same message format. And the idea is that while we are at it, we might actually be good into protecting that stuff instead of just leaving it in the clear. That's it. So it's actually a confidentiality argument for the group message, if I can stretch it.
Yeah, that's true. We've conflated common framing and handshake encryption into one thing here.
So about encrypting the type, I think Joel Alwyn, I think all things being equal, it'd be nice to encrypt that. But if it comes at a price, one thing to consider is that these messages, it's probably in the end going to be realistic to detect what's a handshake message without even looking at the ciphertext or anything, just looking at the timing of when it's sent, because these are automated messages. They're going to be sent according to some distribution. I think traffic analysis is probably going to leak, in reality, a lot of information about whether it's handshake or not. So whether we encrypt it or not, that's going to be the case. So the price that we pay for encrypting it should probably take into account that we're probably going to leak that information in a lot of implementations anyway, or at least use cases. So it's not clear to me that the price is worth paying.
This is DKG. Just to respond with my typical traffic analysis response here at the IETF. You're right that we do currently tend to leak quite a bit of information in terms of traffic analysis. If we go ahead and make decisions that say, oh, well, too bad, so sad, we might as well not bother, then we have no way to actually push for doing countermeasures to traffic analysis in the future, because we'll say, why bother? There's nothing to protect. It's all in the clear. There's a research agenda that's growing right now in academia and in other places to try to do effective countermeasures to traffic analysis. That may be a fruitless project. We don't know. But if we define our protocols in such a way that traffic analysis, that you can't do a countermeasure because data is in the clear, then we've just sort of voided that work. And so I want to caution us against saying, too bad, so sad, traffic analysis wins, because we haven't even really tried. And we shouldn't rule it out by our protocol decisions.
Okay, to make a point here, I think the main problem is that we could encrypt everything, try and decrypt the content type specifically if you want, but at the cost of having to pad the application messages at the same size as the maximum size for check messages, which is probably, to me, it's unrealistic. So I think my point is that we should move to, like, as a first step at least, move to just stay with the content type in the clear, encrypt the sender and generation, and do a next round on trying to encrypt the content type, if that makes sense.
This is DKG again. Okay, so this is my last time at the mic on this issue. If we make this change so that it's in the clear, then the people who do have the use case and who are willing to pay the cost for padding and traffic analysis countermeasures have no way to do it. Right.
We're not committing to keeping it. It is in the clear right now.
Right. So I'm saying we should try to encrypt it. We should try to encrypt it from the outset. It was a pain in the ass to get, to get the content type to be encrypted in TLS, and I think it was worth it that we worked on that. And I don't want to go through that same pain again if we can get it right the first time here.
So this is Madam Mora. So to be clear, handshake messages here, add and remove, or it includes update as well.
Update as well, yeah.
If it includes update, my concern is because I always wanted to patch update with actual user data message. So this should help with traffic analysis. So if you want to add and remove only in this case to reveal the content type, I'm fine with this. If you can patch update or merge update with actual user data message.
I mean, it's true that in TreeChem, I think currently update messages don't have to be strongly ordered. Yeah, I don't know how confident we are that that actually works at this point. So in that sense, yes, we could keep update messages out of the scope of handshake messages. Yeah. But again, I'm not confident that that works as advertised.
This is Joel Owen again. So maybe a compromise would be to make it an extension so that people who want to also go ahead and implement further traffic analysis defenses can then use that extension. And the people who don't want to do that don't have to pay the price for encrypting content, which is only a partial solution to a problem. So maybe that's a good compromise. I don't know.
I think I liked Richard's proposal, which is to table this topic for a little bit. I mean, we've been having a chat on Wire about other ways to attack this problem that might actually give you both behaviors you want. So I think what I would suggest is we take message framing 1, which is clearly easier to execute on, and leaves the content type in the clear, and because I don't think this is the way I'd probably want to encrypt the content type. Or you want two, but you want the content type to be the clear, right? Yeah. Okay. That's what this is. I guess that's what it is. You're right. You're right. Sorry, my mistake. You're right. Sorry. It's a long night. So yeah, I mean, I think given the consensus encrypting these things, let's go ahead with this. And I'm if we figure out a good way to do the content type, then we can definitely do it. And if we don't figure out a good way to do the content type, then we can fight about whether the bad way is better than the thing we got. But I guess I think the commitment we should be making is like, we're going to keep this an open issue and we're going to re-examine it, not just we're going to like throw it on the floor. But I'm like happy to do that.
Yeah, I think that's a good conclusion for now.
I'm filing the issue now.
Good. And then maybe someone can come up with a concrete proposal how we can encrypt the content type and retain maybe the idea of having the strong ordering on the handshake messages. Okay, I think that concludes it. Is next one lazy updates? Or?
I believe the next one is going to be mod, right? Oh, lazy update. Sorry. Yeah.
So that's me again. Sorry. All right. So this is something that we started discussing at IETF 103. Specifically, this only has to do with performance. That's the reason here of what we're trying to improve. It is not to increase security or privacy at this point. And so what was identified is a bottleneck situation where in a multi-device context, a device is being added to an account and then has to be added to all of the groups of that user. So as a reminder, typically in messaging systems that are being actively used, there are many groups. And most of these groups, they're inactive because at some point people were added to the group, they've interacted a bit, and then the group dies after a while. And there's typically no particular recycling around that. But so we are in a position now where we keep up the state of the crypto around that group. So one proposal that has been made is that we could cryptographically shut down groups that are inactive after a while and just keep them on the clients basically and reactivate them if necessary. So that is one way of solving that problem, but that inherently means that MLS is not really capable of having many open groups at the same time in a messenger. The other thing is that when you add a device, and this was, for example, also said by the gentleman from Keybase at the last Real World Crypto in January, in the context where you add a device to an account, you don't have much time and you don't have many resources in general. Potentially you don't have a lot of bandwidth or a lot of processing power. So all of that has led to identifying this bottleneck situation. And so this is a proposal of how updates could be more efficient, particularly in the situation where they need to be issued across hundreds of groups. So how does it work? A regular update has the whole direct path in it, where it chems the value of the parent to its sibling for every level of the tree. In a lazy update, really only the leaf node of the sender would be replaced. And we only send a public key to the group. So to make that more clear visually on the right, the red leaf node is the one that is now issuing a lazy update. So it overwrites the value at the leaf, and the rest of the path, the direct path all the way to the root, is being blanked. So basically there are 4 steps to it. The new leaf node is created, but nothing is being hashed up. The new value is sent to the group, and everybody in the group then replaces that particular leaf node and blanks the direct path. So what is the immediate net result of that is that actually no crypto is done other than creating that leaf node. So this is a very fast operation because you don't have to do multiple Diffie-Hellmans. And potentially we can even reuse a leaf node across different groups. So this remains to be seen in analysis, what the consequences are if you do that. And so this new leaf node can be used by everybody else in the group for HPKE, so you can cam values to it. But it needs to be quite clear, so we don't have any security around that yet because we haven't changed the keying material at all. Key schedule is still the same, so we don't have any forward secrecy, and we certainly don't have any PCS. So in order for this to become secure, there's some rules around it. So these lazy updates, they can be chained, and there could be multiple ones also from multiple senders. However, before anything else is done, it needs to be followed by a real update, which is then going to introduce new freshness. It's going to heal the tree as well. So in particular, when the update is being sent by the same sender as the lazy update, then the direct path will be populated again. But the update could also be sent from a different sender. It's not a strict requirement that the same sender has to send an update. So in terms of efficiency, yeah.
I just can go back to the first slide.
Yeah.
And this is exactly why I was saying earlier, like if you can batch update with regular message, because you are fine as long as no one is sending anything to keep the state as lazy updates. But you need a regular update once someone sends a new data. So in this case, it makes more sense to merge both messages in one big message, like update and the new message data. If you can do the merge.
You mean an update combined with an application message? Yeah. Okay. Yeah, I mean, this would indeed be the case. So if we imagine a scenario where we've had a number of lazy updates because a group is completely inactive, and then somebody wants to send a message, an application message, then that client has to first issue an update. That's true. So looking at the cost a bit, so with a lazy update, we're an O of 1, whereas before we were somewhere between log n and n, depending on how the tree is populated. So this is dramatically faster than a regular update on average. But the costs that we just saved is basically postpone in the sense that somebody else or the same client has to pay the cost later. So the regular update is at least as expensive as it would have been had it been issued initially instead of the lazy update. Potentially a little more expensive because the tree is more fragmented now. But the difference is this can be paid by anyone. So now we can make it about what client or what member has better resources. So in practical terms, a desktop PC, probably on a good internet connection, has fewer problems to do that than, say, an old Android device on a 2G connection. We might save some costs in total, particularly in inactive groups, because it might very well be the case that we never do any crypto operations in those groups ever again. If nobody ever wants to send a message in that group, we don't do anything expensive at all. So we're shifting from an eager strategy to a lazy strategy with that. And operations can be more expensive or a little more expensive, but you might save on a number of operations actually. And so this allows us to do, first to avoid bottlenecks as such, because we can postpone the cost, but we can also have strategies around that where, for example, mobile devices typically don't do real updates unless it's really necessary, where desktop devices can do them eagerly just because they have the time and the bandwidth and they're bored anyway. So we have this sort of flexibility now around that. Of course, it comes with a number of security implications that we would have to look at very carefully. So a lazy update introduces a state that is in between epochs because the old epoch is no longer valid. So a lazy update could mean, for example, that a device has been removed from a user account. So we shouldn't use any key material from an old epoch anymore. But we don't have a new epoch yet, so we're in this void between two epochs. And that needs to be very clear that during that time, you shouldn't do anything except for sending other lazy updates or ending that time with a real update. And so on the analysis level, this remains to be seen, of course, what problems it would introduce. Joel?
Could you just explain a bit more? Why is the old epoch not valid anymore? What's the problem there? I mean, is it just that the new device can't decrypt messages from that epoch, or?
So in the multi-device mode where you have a virtual client that basically has a subtree with all of your devices, if you remove a device from that account, it leads to a change in the subtree, which then gets a new root node value, which triggers an update in whatever group that user is in. So when you see a lazy update, you don't know whether it is because somebody has added a device or removed a device. You have to assume the worst case, which is somebody has removed a device, and then we want to have the usual security properties still. So a little more context here. Lazy updates are very similar to ads. The structure is similar. We don't need an index because lazy update really only can be done for yourself, so the sender is implicit here. And the difference is also what I just said. So ads don't really require PCS. We said that it's good enough to have forward secrecy if the whole group agrees on ratcheting the existing key material forward. We don't need any new freshness for ads. But since lazy updates are not necessarily only ads, that's what breaks the security promises. And then there could also be a lazy remove that works in a similar fashion. I'm not sure what particular problem that would solve right now, but at the very least, it's something that could be considered if it makes sense. So there, we would basically tell the group to remove a certain participant in a certain spot in the roster, and then the direct path of that leaf is also being blanked, but there is no new freshness until an update is being issued. Now we come to the questions. So the first question is, are there better ways to address bottlenecks? I mean, this is one proposal. Maybe there's a much better one. And in case we want to investigate this further, what are the security implications? Do we understand them well enough at some point to be confident here? Okay, it's not as interesting as common framing, I see.
Karthik Bhargavan, Indriya. So answer to the second question is that no, we don't understand the security implications. And because we are quite far behind, I would say, in understanding even what blanking does in general. One thing that was true in the original ART proposal, and we would like to preserve, I think, as we go and do modifications in the protocol, is that we should have pretty easy to understand invariants that are true for the tree at any point in time, whether we are in an intermediate state after lazy update or at the end or whatever. And the more intermediate states like this, where somebody has updated their key but not yet updated the group key we have, the more delicate those invariants become. And invariants are not just important for proofs, it's also because we can easily imagine implementations having desynchronized state and lots of issues coming up because of concurrency or other kinds of weirdnesses in implementations. I think at any point, if I take the state of the group that I have in my device, if I can say something about it, that it is somehow consistent internally, that actually gives me a much stronger basis for reconciling when things go wrong. And there are too many cases here which you will have to think about carefully about how different people with different intermediate lazy update states interact and whether we can actually practically prevent them from making actions between these two states, which I don't understand well enough at this point.
Okay. Yeah, so I think the conclusion is that at IETF 103 we raised some awareness about potential bottlenecks in general. Now we have a concrete proposal here, but more work needs to be done, particularly on the analysis side, to move forward with that. But nonetheless, we have this proposal now, and that is something that can be kept in mind when proposing other changes to see to what extent it would be compatible with that.
Yeah, Richard Barnes. I think this is one where it would be useful to kind of flesh it out a little bit and see a PR. I'm worried about kind of the complexity this is going to introduce in terms of state management, and so it would be helpful to see a slightly more concrete proposal. I do think that there is sort of a potential like refactoring of the algebra of these things. Like it seems like you could express an add as lazy add plus update, for instance, and remove as lazy remove plus update. So, I mean, there may be some conceptual simplification to be had here if we tease out those primitives. I'm just not sure the complexity, as it's currently expressed. Don't quite understand what the complexity implications are right now. So, yeah, I'd love CPR on this.
Yeah, that's a good proposal. Maybe it can be broken down to something that we already have.
All right, thanks. Imad, you're next. So this is an individual submission draft that Imad brought this idea up in the interim. This is an individual submission draft that essentially is, I'm not going to hide it. We're considering doing a working group adoption call. So think of this presentation in that vein. Thanks.
Okay, Damara. We brought this up during the interim last June, and there was some support for it since then. Rafaela and I submitted this draft, and we're looking for. I'll go through it today, explaining the use cases for federations, some challenges, and I'm not looking for any solution for these challenges. Just if there is interest in this doc, we'll try to solve it together later, but not today. So the goal. So we are trying to standardize the minimum information needed to allow different MLS clients to encrypt and decrypt each other's. And this system should support either single shared delivery service or more even complicated multiple delivery services. So there are two use cases in my mind. Like one of them is for web client, and this is a demonstrated single shared use case. Like assume end-to-end encrypted web application, so where multiple web clients can send secure messages to each other. So in this case, MLS will be implemented in the browser, and it will communicate through the app, through the JavaScript APIs. And MLS in the browser will just communicate to the delivery service to retrieve keys. A more concrete use case is using MLS in the browser to set up end-to-end encrypted conference calls, like what we call MLS SRTP. If you have something like this, you can easily key exchange, use MLS to bootstrap the calls and key updates when people join and remove the calls. Another use case is different clients and different delivery services. Like assume like end-to-end encrypted messaging across multiple providers. Like each message provider has their own delivery service, has their own client, and they want this client to talk to each other. And this can be done either in two ways, like client-side fan-out and server-side fan-out. And this use case is much more complicated than the usual one because we have multiple delivery services. So in this example, we have like a group of 4 people, A, B, C, and there are 2 clients from delivery service B. So when B1 tries to send a message to the group, if it does client fan-out, it has to contact all delivery services, including itself. And then each delivery service will just communicate to their client. So B will send the delivery service A and B and C, and each delivery service will just forward the message. This might not scale. On the other hand, server-side fan-out for the same scenario, B will just send the message to its delivery service, which proxy all delivery through other delivery services. So delivery service B will deliver the message to B2 user, and to delivery service A and C, which delivers the message to their user. So what's the scope of this work? So we're only focusing on the crypto layer. Some other stuff that's out of scope for now. So for example, mapping between user ID and which delivery service to talk to, or the URL of this delivery service is up to the application. How different delivery services communicate to each other. Also, less to the application unless it becomes necessary for the crypto layer. So the requirements we see for now is to define the message for retrieving user init keys and identity keys. What's the request? What's our format of the request and the response? So the request should have the remote user ID and what my local supported Cypher suites, as simple as it is. The response would be a list of user init keys, one for each device, and each init key will also have the long-term identity key. Again, this is a challenge we see right now, and I'm not looking for any solution for them today, but I'm just setting them up. Like with most of them are actually coming from multiple delivery service scenarios. For using single delivery service, most of them it's okay. It's the same what we have today. But when multiple delivery service, these things becomes much more complicated. Like for example, how to do versioning Cypher suites. Should we do another version negotiation beside what we have today in user init keys? I expect we might end up doing so because like you don't control like, what version each provider has. And again, handshake message ordering, back to what Rafael was saying, like if TCAM really requires handshake message ordering, how this can be achieved with multiple delivery service, like how do you synchronize the ordering? Metadata sharing, like if there is a state saved in the delivery service, like a roster or any group state, if you're using multiple delivery services, how this can be synchronized across all of them. And last one, multi-device, like if like after you start the group and one device is removed from provider A, how do you get notify other providers in the group like this device has been removed or added, etc., etc. And that's it. So the question is, are people interested in federation use case in general and work together? So I can just speak for myself, and I'm representing Google, and Rafael representing Wire are really interested in this domain and want to see if other people are interested as well.
I'm interested. Both generally, I think it's a good thing, and I'm excited about this part, the thing on the earlier slide where you were like, "Let's put this in the browser," and that makes me like more interested.
Yeah, I knew you would like this.
Yeah, I thought, yeah, exactly.
Know your audience.
This is Daniel Kahn-Gilmore. I'm also interested. I haven't thought deeply enough about whether this is something that we actually could adopt in this working group, but I'm definitely interested in seeing this work progress. Thank you for bringing it here.
So Daniel, on that point, the charter is written to preclude federation at the application layer, but it is open to doing stuff at the crypto layer. So technically it's in scope. We've kind of talked with Ben about whether or not it would work, but I guess your point is whether we should do this now or later or what, right?
I mean, I'm happy that we're thinking about it, and I mean, at the very least, I'd like to make sure that we understand what possibilities we are precluding with any of the cryptographic choices that we make here.
Fair enough. That's exactly where I was hoping you were going.
Yep.
Watson Ladd, I think we should think about federation. I'm just a little confused about why. I think it would emerge what crypto changes we might need to make. I guess I'm thinking along the lines of something like IRC, where you do have messaging and it's spread out, even though there's multiple servers potentially spreading out all those messages.
That's correct, yeah.
Jonathan Hoyland, Cloudflare. I think this is very interesting. And I think the joining MLS into other applications or into other protocols is more complicated than might at first be apparent.
Can you elaborate on this?
So basically you end up having to, I've thought about this quite a lot, and you sort of end up having to create channel bindings that are consistent and hold a lot of state, just because otherwise you can't actually prove that everyone agrees on which MLS session is being used in the later protocol. So if you're running some sort of voice chat protocol separately over the top of this, you can't just say, yes, we're using this group ID and assume everything will be fine. That it's quite complicated. Not that that's a bad thing, just like...
Yeah, it's complicated. I know this for sure, yeah.
Yeah.
So Colin Jennings, I think it's really interesting, and we'd be interested in using it. Sort of, we would probably build products that took advantage of this. We've been going down that path already with not in a browser case, which doesn't require any standardization for almost every use case you can think about. But as soon as you want to do it in a browser, I think we need standardization of how that would all work. So we'd be very interested in seeing that move forward.
So observation and question. The observation is like, I think thinking about the right time in the lifetime of the group to do this work, it seems like for work like this to make sense, you need to have kind of the API of the underlying protocol be stable. You need to know like what needs to be sequenced. You need to know like when you need user init keys and what those are conditioned on. I think the good news, I think we do have that pretty stable at this phase of the protocol. So I think it's an appropriate time to start looking at this sort of work. The question I had is like, what degree of kind of concreteness of protocol are you looking at? Are you thinking about like, is this kind of a general abstract protocol that you might implement in different ways in different contexts? Or are you thinking about making it like an actual concrete definition of how you'd handle this stuff around?
So as of today, it's more of concrete. Like I can imagine this can be integrated in so many protocols, messaging, browser, like we're interested in all of them.
This is DKG. I just want to clarify my earlier comment because I realized I might have displayed enthusiasm for some parts that I'm actually not enthusiastic about. So there's these two different use cases that you've got here, right? You've got this one up here that's on the screen right now, and then you've got, right? So if anyone's listening to the audio channel, I'm much more excited about the other one, the one that's not on the screen right now. I'm more excited about the idea of different clients and different delivery services than I am about the operations in the browser. I'm not saying that it shouldn't happen in the browser, but I want to point out that it's been very difficult for us to get browsers to the point where users have some sense of who they're talking to in the browser.
Yeah. So
and if we turn and we have this regular fight in TLS, like trying to keep TLS a two-party protocol. And if we decide to try to make some sort of standard MLS multi-party protocol in the browser, I think that the security model for what people think is happening in the browser will be even more disastrous than it currently is. Ecker asks, is it possible to be even more disastrous than the current browser security model? Yes, it is. And I'm warning us, like, let's make sure we don't make it worse.
Sure. Just to be clear here, I'm not choosing one use case over the other because I heard some people support use case, some other people support the other use case. The idea of the current draft is to support both. So we're not picking one over the other. But I understand the concern with the web story.
Thanks.
Karthik Bhargavan, Inria. So in general, I think this is a desirable feature to have. One thing that I'm a bit concerned about and like to understand better is that in standard MLS, every member actually knows the full membership of the tree, the roster, the full group state and stuff. Federation will naturally lead, I fear, to cases where one organization would like to hide some part of the tree from the other. So, I mean, just as a way of composing these things, you may not actually want to transfer the whole tree state between the two. Now, I think the proposal here is actually it's completely transparent. It's just going through multiple delivery services. But that's not how other federated systems work. They do hide things underneath subtrees.
Yeah, this is exactly why I brought up the multi-device, because some system might handle multi-device are different than each other. And you might just end up delivering to one device and define out to other devices in this network handled by this provider.
Right. So the moment we kind of expand out those kinds of use cases, and if one of them actually becomes the standard one, I think the security analysis becomes much more interesting, and we need to think more about it, because also so far we have, since with one delivery service, we've actually said there is very little trust in the delivery service. There's a lot of trust in the authentication service, but not much in the delivery service. And with multiple authentication services and delivery services, we will have to think more closely about what subset of things could get compromised and what guarantees we get and so on. As such, I think we just are assuming that all of them are trusted, and that would be the only default case we would have. So this is not giving us decentralization for sure. It's giving us federation, but we don't get any,
That's correct.
Richard Burns, just to be clear, I would expect whatever federated thing we end up with here to have the same security properties in terms of authentication and visibility that the base protocol has. Right. This is just talking about how you tie together multiple delivery services and like distribute that crypto conversation over multiple delivery. Like it's just a change of transport. With regard to things like hiding things underneath subtrees, like there's nothing you can do to prevent that anyway. Like even in the base protocol, someone could always choose to distribute the private key for their private key, their identity key pair around to other devices and manage those as a consolidated thing and appear as a single device in the group. So I don't think that's really the type of hiding we need to account for here.
This is DKG. I want to second Richard's point there. In fact, the assumption right now, I'm actually a little bit concerned that we've just made the assumption that all devices will be exposed to the delivery service. Because my understanding was that we have this ambiguity in the protocol that I actually prefer, which is that I don't need to expose my devices. I can potentially use my own internal MLS session so that my own devices can produce a key that then becomes one key that's part of an MLS session. I actually think that if we're going to make an architectural decision that explicitly says all devices need to be exposed directly to the delivery service, I think that's a mistake. I don't want to run this in that operation. And so if you think that the cryptographic analysis changes significantly when we've got subtrees, I want to know what those differences are, because to my mind, that metadata hiding is actually a useful thing, and I would hope that people would push for that to be the default.
Sure. I will let Rafael respond to this. I know he's working on multi-device story. But what the architecture draft has today is assuming all devices are exposed. Like each device has its own identity, which we can change. But I don't want to limit the federation conversation to the multi-device story. We can take response from people. I don't know spend. I don't know if it's a controversial topic, but I know Rafael and I are working on multi-device story, and I can respond into more details.
Yeah, just like to add to that I'm currently in the process of writing up something, and then others will chime in as well, to clearly document how the two multi-device modes we've been thinking about actually work, and also so that we can then see how that works security-wise in terms of analysis. Because for now, we've been floating these ideas. We've been saying we can hide devices of a certain user account under a private subtree, but we've never really written it up. We've never thought about all the consequences of that. So this is something that is going to happen now, and that becomes even more relevant in the context of federation, of course. So I don't really see how it is mandatory that all devices are exposed, in the sense that if we are confident with the mode where devices are hidden behind a virtual client, that is something that can absolutely be used in federation, and then therefore nothing is leaked around individual devices.
To clarify what I was saying earlier, I don't think that all devices are exposed to the delivery service, but I think all devices are exposed to all other members of the group. That's what I was saying. So in our analysis, actually one of the architectural goals was that when I receive a message, I know who the rest of the members of this group are. And this members is an abstract thing right now. It's clients, maybe one day it'll be users or whatever. Now, hiding devices is actually a great idea. But as long as we were saying that we are hiding all the devices belonging to a single user, I could still kind of get away with it by saying, the member is actually the user who's hiding his devices underneath. Now, if you're going to say that, the members, what I'm going to hide is actually a group of all Google members are hidden actually from all Facebook members. Now, the guarantee, the goal in the architecture document that I should know who all are the members of this group becomes significantly weaker. And we just have to be sure that that's what we mean in this situation. Yep.
Okay, so it's great that the draft doesn't answer all of the questions. There's actually some work to do, which is what the working group would do. So what I want to know is, would there be anybody that would be in violent objection of adopting this as a working group draft? Okay, so with that said, and since it only came out like 2 weeks ago, I think what we'll do is we'll take the working group adoption call to the list. And so, like I said, it seemed like there was support here. I will note that in the message that we send to the list, then people can chime in there so that we can do our consensus call based on that. All right.
Thank you.
Thank you very much, Ahmad. And next we have deniability. So hopefully Sophia is there online. I see her now. Hopefully she'll hit the button.
Can you hear me?
We can hear you fine.
Okay, nice. Just a small question. When I want to change the slide, I have to say next, right?
Yes.
Okay, awesome. So, okay, hi, my name is Sophia, and I'm going to present about deniability in a group chat setting. Just a little bit disclaimer around here. This came up because we were doing a review of from from the OTR world, we were doing a review of the current drafts of MLS, and we noticed in certain parts that there was some references to unlinkability and repeatability. So we were wondering if deniability, repeatability, or unlinkability was actually something that MLS wanted. So I wanted to make this presentation to see if people actually want deniability in it or not, or what limitations do they want. So yeah, next. Okay, so just a little bit of a context that I'm sure that everybody or almost everybody in the room already know. Of course, deniability comes from the first proposal of OTR as a messaging protocol, in which it was proposed the idea of secure communication and having a secure way in which messages are encrypted and signed, but at the same time that you have this authentication through the usage of signing, you will also have a deniable way of actually authenticated a participant into a conversation. And this came from the idea when OTR was first proposed that secure communication over the digital world should actually mimic what is often referred as real casual work conversations. And in real casual work conversations, the people often have deniability in the sense that no one can actually prove to anybody else that someone participated into a real conversation or said something in the conversation, or sometimes even that the conversation actually took place. Other protocols took inspiration from OTR for this. The Signal protocol took inspiration from this. The OWN protocol took inspiration from this. But at the end of the day, it has only been defined deniability in the terms of conversations of two participants. Because during that time, there was only this thinking that the conversation would have been over two participants. But in today's world, is not that we have a new communication approach with group chat, but actually that group chat in a secure way is often more thought about, because on work we use group chat actually to work, and it's more often used in the real world. Next. Okay, so basically, what is deniability? I'm sure that most of the people here know. It's basically the property by anyone can actually deny having said something in a conversation or having participated into a conversation. This is often accomplished by the use of forgeability or malleability inside of protocols. What deniability is not is that it doesn't prevent from someone knowing that a conversation took place. The only thing is that there's no link between the identity of someone and the fact that a conversation took place. Next. Next.
So we're on properties with the confidentiality, integrity.
Okay. Okay, so I also wanted to give a little bit overview of the different properties that in general secure messaging protocols have. And of course, this is defined by a very well-known paper that was written by Unger et al., in which there was this little bit of a listing of the properties that a secure messaging protocol should have. Of course, there's already some properties that I'm sure people know here, but important ones in terms of deniability is, of course, authentication. Something that Ian Goldberg has defined in terms of authentication is that it should be entity authentication, meaning that if someone proves that that in order to prove that a public key actually belongs to someone, you have to prove knowledge of the secret key related to that. And origin authentication in the sense that you will also have to prove that there's a well-defined source from which a message comes from. Of course, in terms of group chat, something that is very, very important is to have good participant consistency, that some people have already talked here in the room, speaker consistency, causality preserving, and a global transcript. And these properties are actually very important when talking about deniability, because some of these properties get limited because of actually pushing some deniability properties. So next. Okay, in terms of deniability properties, when this paper was first written, there was some definitions of deniability which no longer hold today. Like, for example, there was this notion of message unlinkability and message repudiation. Today, basically, these two properties are actually called message deniability, because this actually talks about the fact that if you are having a conversation, you can deny having said a message. And there's another property related to this, which is participation deniability, which actually says that someone can deny having participated into a conversation. There's other properties that are actually also related to deniability, and that are related to the fact that deniability properties are pushed into a group chat. Like, for example, trust equality. Why? Because some group chat protocols have actually defined that they will use a trusted server to achieve deniability properties. And sometimes, especially from the OTR world, this is actually something that doesn't want to be accomplished, because there's this idea that you should not trust servers, because they can be the point of failure. And of course, there's other properties from group chat, like contractable membership, expandable membership, that I'm sure people in MLS have already talked about. That is, for example, removing a user from a user chat or adding a user to a group chat. Next. And of course, there's other additional properties that are fundamental to group chat, like, for example, out-of-order resilience and drop message resilience. That I'm sure that is something that MLS actually wants, because one of the goals that I heard that MLS wanted in the Real World Crypto presentation is that they wanted to be a protocol that is asynchronous. So this is basically a property of a synchronous protocol. Next. Okay, and now to talk about the new deniability properties, and this is something that we have been pushed forward in the version 4 of OTR. As I said, in the past, there was these terms about reputability and linkability. Right now, in the current papers and academia, is more often referred only as deniability. And deniability now is often referred in terms of judge, a person that is judging if someone participated or said something in a conversation. And this oftentimes is referred as only deniability, in the sense that even during the execution of the protocol, if someone is colluding with someone in the protocol, there should be no way to provide evidence of participation or that someone said a message in a conversation. And often offline deniability, which is often the one that we often think about, because it is the one that we explain when after the fact that a conversation happened, if you have a transcript, someone or anyone could have generated that transcript. Next. Okay, and what work has been already done? The first work that was already done was by Bayan et al. And it was the first work in which there was this trust on a server to actually create a group chat and give deniability properties for it. But it was proven by Ian Goldberg et al. That it was actually not a good construction, because it put the full trust on the server. Because of this, Ian Goldberg et al. Proposed the first multi-party of the record messaging, but it has also been proven that it didn't give all the deniability properties that it was wanted. And of course, it didn't give forward secrecy, so it was not a great idea. And it was quite often very criticized by the Signal protocol, because the Signal protocol called the MPOTR it defined it as a very complex protocol that actually didn't attain what it needed to attain. So one of the most used protocols right now in terms of group chat is, of course, the Signal protocol. And the Signal protocol has been also criticized in these terms, because it puts a lot of trust on the server to actually achieve participant consistency and speaker consistency. And it also has not been mapped in a correct way what are the deniability properties of the Signal protocol in the terms of a group chat. So, for example, the new properties of deniability of like online deniability and offline deniability have not been proven in this kind of chat. There has been some other research that's currently happening, especially led by Nicholas Hopper, that is actually trying to push these new properties of deniability into a group chat setting. Next. Of course, then just to briefly say about the limitations, just so people know, of course, there's no clear, still today, no clear understanding which properties can actually be achieved by a group chat setting in terms of deniability, because there's no good understanding of how offline deniability and online deniability will look in a group chat setting. There's also not a good analysis of what types of deniability have been actually given by the protocols that I just referred to. there's only one table of comparison that has been done by Nicholas Hopper et al. So there has not been a really good analysis of it. And as I said, there's no inclusion of the new definitions of deniability. The new definitions are just being pushed forward in the last few years. So yeah. So in terms of MLS, I would say this can be something to be pushed forward. But if, for example, the working group decides that they only want some kind of deniability properties that were already defined in the past, that's also that can be done. But the limitations are very good, very big, because in the sense that there has not been a real analysis of what, how can deniability properties will look like in a group chat setting. Next. Yeah, and that's all. I tried to keep it very short because I didn't have a lot of time, and there's the reference if people want to read about it.
Thank you for doing this remotely and keeping it on point. Appreciate it. Raphael.
Yeah, I'll be very brief. Thank you, Sophia. So I just wanted to mention that there have been numerous talks.
Sorry, is someone talking? Because I don't hear anymore.
Can you hear me?
Yes, okay, yeah, and I can hear you now.
Great. So just wanted to bring up that there have been some discussions about a relatively cheap version of deniability that could be combined into MLS that would probably give you message deniability. And that would essentially work like sender keys with Signal, where the signature key would be delivered out of band over a deniable channel, so that when the messages are signed with that, you cannot directly tie that to an identity. But it's not a very strong norm of deniability. But it's something, the only concrete thing we've ever been discussing so far. Just wanted that to be on the record.
Yeah, I saw, because there was a response to an email around that, and I saw about that. It's just what you want to attain about deniability, because it's completely fine if a protocol in its security properties says something like, we only achieve weak message deniability in this sense. That is completely fine, but I don't know if that is something people will want to attain in the working group.
Nalini Elkins, Inside Products. I think if we do something like this, it should be optional because, for example, a lot of our enterprise customers, if they want, they're mandated to, watch certain trades, certain customer interactions. And so if we transparently tell them that we're monitoring your call for, service or whatever, and then later we can't prove that we did that, that gets us into trouble with regulators.
Yeah, I think I will agree on that. There was a GitHub issue that the working group had about if they wanted to have like completely deniability, no deniability, or like optional deniability. Maybe something that would be nice is actually giving us optional, because it will give users of the protocol a choice between what they actually want to give.
This is Daniel Kahn-Gilmore. I just want to observe that anybody who's doing current telephony or SMS-based customer service already has this problem with deniability, because those protocols don't offer any cryptographic assurances whatsoever. So if we think that regulators are going to take issue with lack of cryptographic verification, which is what we're talking about here for deniability, then those regulators are severely under-resourced at present.
Harald Alvestrand. Just one thing I don't understand. It might be obvious. When you say deniability, do you mean deny towards anyone who was not a member of the group at the time, or deny including to members of other group, of members who were in the group at the time?
Okay. When you are having a conversation with some group members of the chat, you will have to, that the people on that group chat will actually have to know that they are talking with the right person. That's why in the terms of deniability, you often call deniable authenticated, because the people that is actually talking through the chat with do need to know that they are talking to the right person, to the authenticated person. But anyone actually looking from their side after the conversation happened should not be able to provide proof of that any participant actually participated in the conversation, or anyone who is interacting with a participant in the conversation should not be able to provide proof that a participant participated or some message was actually said by someone in the conversation. Is it clear?
Okay, so of course, if a member is attesting to you having said something in the conversation, then there is a kind of proof, but it depends on the honesty of the person making the attestation. So I think I see what you mean now. Thank you.
Okay.
Hi, this is Richard Barnes. I think I agree with what some other folks have said. This is probably going to need to be an optional feature of the protocol because we have these cases where we need the opposite of deniability. That said, I think it would be interesting to look at kind of some cost-benefit trade-offs here. Sounds like, there's these various flavors of deniability, and I think it would be interesting to see what are some of the approaches that one might take to adding this as an optional feature of the protocol. We've discussed, as Raphael pointed out, some kind of exterior versions where you could kind of set the inputs to the protocol to things that would be deniable, and there might be some other more in-band things. So I think some pull requests here or some fleshed out proposals would be welcome, because I think we kind of need, in order to decide what the next steps are, we kind of need to understand those cost benefit trade-offs.
Yeah. So
yeah, I agree on that. Okay, sorry.
No worries. I was going to just kind of do the wrap up here because we still got one more presentation.
Okay.
So, yeah, thanks a lot for this presentation. My summary is that we should explore this idea of deniability, maybe thinking about it as an optional feature, but trying to figure out what the bounds are and what properties we'd actually be looking for. So thanks a lot for that. All right, Karthik, you're up for analysis. We're gonna have to beg your indulgence, working group participants, because we're a little bit over time. So you're losing time on cookies.
All right, so I'll keep this pretty quick. I thought it was important to give the working group a little bit of an update on what's going on, what we're doing, and also for me to be able to collect information from others whose work I may not be aware of. So it's just a brief update on what's happening in the security analysis realm. So the first thing to realize is that MLS already is growing to be a pretty big protocol. There are many, many key components, and people are looking usually at one or two of these components, but not everything, and this you should expect. So then the papers that will come out on MLS will be on one of these components, assuming a lot of things about the others and not about the whole thing, at least for a while. So we all are aware of the key exchange bits. This is the most studied part. There was the ART proposal in draft 0, which has a nice paper attached to it. There was a TreeChem proposal in draft 1, and now we are at TreeChem plus blank nodes, and there are new proposals coming through as well, including some which you have heard of today. So there's a lot of activity in this zone. There's also been some proposals on how to do authentication, what the credentials should look like, how to compose signatures and MACs to do the right thing. And this has had some analysis, but not too much, because this is still kind of a moving area. And there has been some work on message protection, which was presented last IETF here in the interim and so on what the key schedule should look like, how application messages and handshake messages should be protected and so on. And this, again, is very recent. And there's a lot of work to be done here, and not enough people are looking at it. What I do know of people looking at, and I'm sure I'm missing people, so please let me know what you're doing so I can actually represent you to the working group and make sure that you are aware of any changes coming up and so on. There's a bunch of people who have been doing symbolic analysis, including us and Proverev. There are a couple of Tamarin models, one that was for ART and one for that Richard has been working on for some of the other components. On the crypto side, from crypto proofs, I know at least that Joel and Yevgeny and so on are working on something, and I know there's something else coming out maybe from Conrad and Brittna and so on. But this is still early days, and mostly is focusing on the key exchange, I would say. And Benjamin is working on a verified implementation. It's going quite well, but these are all like, none of them is at a stage where we can say they're done. I would say we are at the stage where we are still trying to understand what the security model and the definition should be. And I think that's getting pretty solidly defined for the key exchange bits, but not necessarily for the other bits. And so all the proposals that are coming out are making me even more nervous, because we are not even, we haven't solidified what we have. before we can even comment on what federation would mean, for example. But you can expect, I would say, by the next IETF or something, a few papers, if not at least one, on the core key exchange bit, which would be TreeCam plus blank nodes or minus blank nodes. We don't know what people will end up publishing, but that's sort of where we are. So there were a lot of components I showed you before, not so much analysis so far, but in a way, one of the issues, I think, when I've been speaking to academics and trying to get them interested in doing this analysis, is that the process seems too dynamic. So people don't know where to analyze and what to analyze. So in particular, we've been doing lots of comments on GitHub, and then some of them make into drafts just before IETFs. But we don't really, a lot of people don't have I'm very involved here, so I do have a reasonable idea of what's going on. But a lot of people don't know whether it's stable enough to analyze, what they should analyze, what will suddenly change under their feet, because each analysis takes a significant amount of time and effort. So I'm going to make 2 process proposals, and I'll take it on the list so we can all discuss this in a bit more detail. And these are sort of like asks from the academic community. Kaz supposes, Ketchel supposes, I and Ben think these are good ideas. But I'm sure that other academics would agree with this as well. The first one is that in the learning from the TLS process, actually we had so many drafts, but there were only like 4 key drafts that were actually analyzed by most people, because that's where the main changes kind of baked in, they got stable, and they didn't change for another 5, 6, 7 drafts actually. So I would like to have that sort of more baked in here, so that when we are publishing a new draft, we also publish along with it, maybe in an appendix, saying which sections we think are now ready for analysis, so that academics can publish papers saying we analyze MLS draft 05, which the authors told us these 5 sections were ready for analysis, and here's our contribution to the process. So those sections should be designated as ready for analysis. Other sections should be designated as don't look at it, don't bother, because we will change this right now. So it'll be a waste of time. And of course, we can change minor details like wire formats and whatnot. But what you should promise is that at least for a few drafts to come, maybe at least for 1 IETF cycle, if not for 2, there will not be major changes in this bit. So it's actually worth the effort for the academics to actually do something there. And I think that'll be very useful to get more people kind of actively contributing here, or not feeling too frustrated with the process. All right. The second thing that I will note already, which is true for TLS, is true here, and here it's even more so because a completely new security model, is that a lot of the work we are doing is just trying to get the definitions in place, trying to understand what the assumptions are on who is compromised, who's not, what kind of privacy guarantees we want, confidentiality guarantees we want, and it's been quite painful already for the basic protocol. It'll be more painful as we add more features. So for now, we are taking, I think all of the groups are working on it, are taking what the architecture states as goals of the protocol as the starting point. And we will try to formalize them as well as we can. We can all debate whether we're doing it right or not. But let's assume that that's done. So at least for the new features that are coming in, anybody proposing a change to the protocol, a new proposal, we would like to have at least a minimal sort of process protocol where when you're proposing a new feature, you should try to at least informally state what the security goal or the performance goal that this new feature is intended to solve, why the previous design doesn't solve this, why the new design solved this, and importantly, and Kaz asked me to put this in here, why the new proposal does not break any of the other goals that we already have. And this is something that we have to do as academics for sure, but I think it also makes sense to have that, upfront as why the person proposing this change thinks this. And I think if we can put major pull requests with these documents in them, just text, right? Just informally, but we don't even understand them right now, why certain changes happen. I mean, I have been quite involved, so I might be able to help some people understand why we made certain changes, but a lot of people don't understand why this happened or why that happened. And I think it's nice to be explicit about these things. And that's all I have here.
Yeah, Martin Thompson, quick question for the working group, I think, based on Karthik's request here, which I think at some point it's reasonable to have. Does the working group think that the protocol is sufficiently stable that having this sort of process is appropriate? One of the things we found in Quick recently was that we had to make the decision to move to a process that's much more like this one in the sense you have to demonstrate that you have much stronger evidence for changes than otherwise, and much greater support. And that does or can slow things down.
And so the question is, does everyone think that this is appropriate? Is the protocol sufficiently complete that moving to something a little more rigorous is appropriate?
Just a small clarification. I mean, in presentations like this, anyway, we are going to discuss as whether people think it's a good idea or not. I don't think I'm asking for like a full justification of whether it's a good idea.
No, I don't think it's really the problem here. Obviously, you can ratchet this up even higher than what you're requesting. And I suspect that in a lot of cases, people are making these arguments that you're talking about. You're just asking for them to be made a little clearer and more formally. And I think that's a reasonable request. But you have to understand the costs.
Okay, we're well over. So if anyone hasn't signed the blue sheets, please do it. And this will be the last comment, Richard.
Yeah, just a quick +1 here. We've also been feeling this pain in terms of interrupt testing, like the evolution causes pain there as well. Which version are you targeting? How can we interrupt? So yeah, I'm definitely keen on having a bit more stability. I think that the upcoming 0.5 version will naturally have a bunch of stuff that is naturally coming to a stable point. And so I think we should be able to do both this conversation about which things are ready for analysis and which are ready for interrupt testing.
Okay, so the last point on the agenda was talking about the next interim. So there is going to be a secure messaging workshop at Eurocrypt in mid-May, and we'll be putting a poll on the list with respect to whether or not we want to have something before or after, likely in Germany as well, likely at the Wire headquarters. So we'll take this to the list. Thanks everyone for coming to MLS.
Good to see you, man.